let S, which is equal to I over Y. So the above function where stress max or stress allowable will be equal to M over S. Okay, and if you look at units, okay, if you look at the units, this is in meter cube. Now, why are we doing this for? Okay, so if we were to look into, sorry, everything is in inches. Okay, it can be inches cube or meter cube. Why are we doing this? Because this is given in the table. You can see over here, this is the S that's given, right? Right. So how they calculate that value, right? So we pick a typical value. So we know that over here the first one, you all can see 833. Yes or no? You all can see. Let's pick W12. Okay, I'm going to look at on a different screen. So W12 times by 96. We are given that IXX is equal to 833. And we are also given that ISS or XS is equal to 131. So from the table, we know that Y, right? Y is equal to D divided by 2. So for that case, it's 12.7 divided by 2, which is equal to 12.7 divided by 2, 6.35. Okay. So we know to calculate XX is equal to 833 divided by 6.35. Okay, so 833 divided by 6.35 is 131.181 inches cube. Okay, but the table has such a value given. Okay, has such a value given. We are going to use the table. You can see the table down here. Over here, you have the what? 131 over here. Okay. So from here, we now know that so now we are going to calculate our I over Y, which is equal to our S, and this will be equal to 324 times 10 to the power 3 divided by 24 times 10 to the power 3. Okay, so 324 divided by 24 is equal to 13.5. So now we look at our table. Okay, we look at our table. Okay, so I'm going to zoom in, right? Okay, we're going to zoom in or zoom out a bit. Okay, I believe you can see this. So we are going to look at 13. We are going to look at XX. Okay, let me copy this. Okay, let me copy this. And let me, and let me paste it on the next page. And the value we are looking for is 13.5. Okay. So we know that we have to select a beam. where S must be greater than 13.5 inches cube. Okay. So now we start looking. Okay. So we start from W8, 13.5 above that. So you can see this. Okay. You can see this. Right. This is 15.2. Okay. So we can use W8 by 18. I'm going to see the S. So the S is 15.2. The area is what? The area is 5.26. Okay. Then no point using any higher than that. Okay, because it will be more expensive if you look at the cross-sectional area. Okay. Then the next one that we can choose, right? The next one we can choose is W10 15. Right, we can select W10 15. And the S value is 13.8. And then the weight or the cross-sectional area is 4.41. So the smaller the cross-sectional area is a good thing. Okay, it means it's lighter. And then the next option that we're going to pick, okay, is this one. Right? So we can use W12 by 16. It's 17.1 stronger, but it's 4.71 cross-sectional area. Okay. So let's say in industry, you are given these three material or these three choices. Okay. Your number one choice will be this one, right? Solely because of the cross-sectional area. Because the cross-sectional area is related to the weight. Okay. Then the second one, this is number 2. And it's not available, this will be your number 3 choice. Are we clear? So that's how you do selection. So we pick our number 1. Okay. So we are going to use W10 by 15. Okay. Now we are going to look into this cross-sectional area now. Okay. So we know, right? So now we are going to calculate principal stresses. Okay. So from here, we have selected this, okay, based on S, right? We base on just the normal stress. Okay. Just the normal stress over here. Or just the normal stress, sorry. Just the normal stress over here. Okay. So now we know for the fact at this point, right, we have a combination of normal stress and shear stress. So what we are going to do next, we have to ensure that the stress max or principal stress is less than the allowable of what was given to us, the allowable of 24. Okay, 24. Okay, 24 times 10 to the power 3 psi, and the tau max. Okay, later on we're going to calculate our tau max. Also must be less than what I'm looking for the value 14.5 times 10 to the power 3 psi. Okay. So the first thing we are going to do now, okay, we know that failure will occur down here. Okay. We are going to calculate the stress state at that failure point. Okay. I repeat again, we are going to calculate the stress state at that failure point. Okay. So if I were to draw our transformation, I'm going to follow what we have over here. So y and z. So this is our y. And then this is our z. Okay. So if we were to look into our element, we are going to place the element. Okay. We're going to place the element at the level 5. Okay. Which, where's the 11.25? Okay. Which is over here. Right. So this is our x and y. Okay. So if I'm going to draw our element, okay, so our element now, which is x and y, and I'm going to incorporate a z. Okay, so this is our element. Okay, it's not so obvious. Hold on. Which is the in plane. And I want you to pay close attention. Okay, like this surface over here is this surface over here. Okay, I want you to draw your attention to that. So now we want to determine what is our stress X. And we also want to determine what is our shear XY and our shear YX. Okay, now we're good. We're going to do this. So stress X is straightforward. So the moment we know is equal to what? Is equal to 324. Is it 324? Moment is equal to 324 times 10 to the power 3. Right? And then our y bar, okay, so that distance, so is d divided by 2. So d, which is 10 divided by 2, minus by tf, wef is equal to 0.27. Okay, 0.27. Okay, so 0.27. And then our IYY, okay, IYY is, or the IX is 68.9. Okay, so this is 68.9. So what we get, 5 minus by 0.27, that's by 3 to 4 power 3 divided by 68.9 is equal to 22.242 or 243 times by 10 to the power 3 psi. Okay. Now, if you see the working from the answers, it's not the same because we are calculating based on where failure of this point. Okay, we cannot just so if you look at the solution manual, okay, if we were to look at the solution manual, which is done by the, if you look at the solution manual, where's my mouse? Yep, they just use the formula like this, which is wrong. Okay, because they did not calculate based on failure. Remember what I taught you in lecture? You have to calculate based on failure. Okay, based where failure is. Okay. Right. So the next one, we are going to calculate our shear XY. So we know that this is equal to Vy over QZ Okay. Oh no, QZ or IZ. Okay. And then this is QZ.